Hi, I'm Andre Emmanuel Manalo from grade 10 SVB. My topic is permutation and combination. Permutation versus combination. What are? Both are ways to count possibilities. The difference between them is whether order matters or not. Consider a poker hand. Ace diamond, 5 hearts, 7 clover, 10 spades, king of spades. Is that the same hand as king of spades, 10 spades, 7 clover, 5 hearts, and ace of diamonds? Does the order the cards are handed out matter? If yes, then we are dealing with permutation. If no, then we are dealing with combination. What are permutation? A permutation is an order arrangement of the elements of some set we call S. Let S equals A, B, and C. CBA is a permutation of S. BCA is a different permutation of S. An R permutation is an ordered arrangement of R elements of the set. Ace diamond, 5 hearts, 7 clover, 10 spades, and king of spades is a 5 permutation of the set of cards. The notation for the number of R permutation is P and R. The poker hand is one of permutation 52 to 5 permutation. The number of poker hands, 5 cards, P. 52, 5 equals 52 times 51, 50 times 49 times 48 equals 300 million 875,200. Number of initial blackjack hands, 2 cards, is 52, and 2 equals 52 times 51 equals 2,652. Our permutation notation, the poker hand is one of P 52 5 permutation. And this is the formula. P and R equals N minus 1 times N subtract 2, then N subtract R plus 1. Here's the formula. Our permutation example. How many ways are there? Are 5 people in this class to give presentations. There are 27 students in the class. 27, 5 equals 27, 26, 25, 24, 23 equals 9,687,600. Note that the order they go in those matter in this example. Permutation formula proof. There are n ways to choose the first element, and 1 notation. Ways to choose the second. Notation 2, ways to choose the third. Notation R plus 1, ways to choose the R element. By the product rule that give us P and R equals N, subtract 1, okay, N subtract 2, then N subtract R plus 1. Permutation versus R permutation. What are? R permutation choosing unordered 5 cards handed is P52-5. When people say permutation, they almost always mean R permutation, but the name can refer to both. Permutation choosing an order of all 52 cards is P52, 52 equals 52. Thus, P and N equals N. Sample questions. How many permutations of A, B, C, D, E, F, G, and with A? Note that the set has 7 elements. The last character must be A. The rest can be B in any order. Thus, we want a 6 permutation on the set B, C, D, E, F, G. P66 equals 6. We times that, it gives us 720. Why is not P76? Combination. What if order doesn't matter? In poker, the following two hands are equivalent. Ace, 5 of hearts, 7 clover, 10 spades, king spades, 10 spades, 7 clover, 5 hearts, and ace. The number of art combination of set within n element where n is non-negative and ORN is C and R equals N R and subtract R. Combination example. How many different poker hands are there? 5 guards. Combination 50 to 5 equals 52. 5, 52, subtract 5 equals 52. 5, 47 equals 52 times 51 times 50, 49 times 48 times 47. And 5 times 4 times 3 times 2 times 1 times 47 equals 2,598,8,960. How many different initial blackjack hands are there? Combination 52 2 equals 52 to 52. Subtract 2 equals 52 to 50 equals 52, 51, and 2 times 1 equals 1,326. Combination formula proof. Let combination 52 and 5 be the number of ways to generate unordered poker hands. The number of ordered poker hands is 52, 5 equals 311,875,200. The number of ways to order a single poker hand is 5. Is 5 to 5 equals 5 equals 120. The total number of unordered poker hands is the total number of ordered hands divided by the number of ways to order each hand. Thus, combination 52, 5 equals permutation 52, 5 or 5, 5. Let combination notation and R be the number of ways to generate an ordered combination. The number of ordered combination I and E are permutation is permutation and R. The number of ways to order a single one of those are permutation P are R. The total number of unordered combination is the total number of ordered combination IER permutation divided by the numbers of way to order each combination. Thus, combination and R equals P and R, or PRR. And this is the formula. Combination and R equals P and R, or PRR equals N notation N and R, or R reputation, R to subtract R equals notation. Reputation, notation, subtract R ulit. Bit strings. How many bit strings of length 10 contain? 10 contains. Exactly for 1S. Find the position, the for 1S. Does the order this position matter? No. Position 2, 3, 5, 7 is the same as position 7, 5, 3, 2. Thus the answer is C. Combination 10 to 4 equals 2, 10. B. At the most for 1 S, there can be 0, 0, 1, 2, 3, or 4 occurrence of 1. Thus the answer is C. Combination 10, 0 plus combination 10, 1 so far equals 10, 1 plus 10 plus 45 plus 120 plus 210 equals 386. How many bits? How many bit strings of length 10s? At least 4 ones. There can be 4, 5, 6, 7, 8, 9, or 10, or parties of 1. Thus, the answer is combination 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 equals 210 plus 252 plus 210 plus 120 plus 45 plus 10 plus 1 equals 848. Alternative answer, subtract from second 10th power the number of strings with 0, 1, 2, or 3 occurrence of 1. An equal number of ones and zeros, thus there must be 5 zeros and 5 ones. Find the position of the 5 ones. Thus the answer is combination 10, 5 equals 252. Corollary 1. Let n and r be non-negative integers with r and n, then C, combination, notation and r notation equals C and n subtract r. This is the proof of the formula. Example, there are 5 ways to pick a 5 poker hand. There are combination 50 to 47 ways to pick a 45 card hand. Permutation 52 5 equals 2,598,960 equals P permutation 52 to 47. When dealing 47 cards or picking 5 cards to not deal, as opposed to picking 5 cards to deal, Again, the order the cards are dealt in does matter. Combinatorial proof. A combinatorial proof is a proof that uses counting arguments to prove a theorem rather than some other methods such as algebraic techniques. Essentially shows that both sides of the proof manage to count the same objects. Most of the question is this section are phrased as find out how many possibilities there are if. Instead, we could phrase each question as a theorem. Prove there are X possibilities if. The same answer could be modified to be a combination, to be a combinatorial proof to the theorem. Circular settings. How many ways are there to seat 6 people around a circular table where seatings are considered to be the same if they can be obtained from each other by rotating the table? First, place the person in the northmost chair, only one possibility. Then 5 place other people. There are 5 equals 5 equals 120 ways to do that. By the product rule, we get 1 times 120 equals 120. Alternative means to answer this, there are permutations 6 equals 720 ways to sit the 6 people around the table. For each seating, there are 6 rotations of seating. Thus, the final answer is 720 or 120 equals 120. Horse races. How many ways are there for 4 horses to finish if ties are allowed? Note that order does matter. Solution by case, no ties, 2 horses ties, 2 groups, or 2 groups of 2 horses tie. 3 horses tie with each other, all 4 horses tie. The number of permutations is P for 4 equals 4 equals 24. There are C for 2 equals 6 ways to choose the horse that tie. There are P 33 equals 6 ways for the groups to finish. A group is either a single horse or the 2 tying horses. By the product rule, there are 6 times 6 equals 36 possibilities for this case. There are combination for 2 equals 6 ways to choose the 2 winning horses. The other 2 horses tie second place. 3 horses tie with each other. There are combination for 3 equals 4 ways to choose the 2 horses that tie. There are 5, 2 equals 2 ways for the groups to finish. By the product rule, there are 4 times 2 equals 8 possibilities for this case. All 4 horses tie, there is only one combination for this. By the sum rule, the total is 24 plus 36 plus 6 plus 8 plus 1 equals 76. A last note of combinations. An alternative and more common way to denote an R combination is combination, notation, reputation equals notation and R notation. And thank you for the listening.